Okay, hi and welcome to a section of video notes on graphing parabolas where this time we're going to focus on graphing with the vertex form. As we can see in our little table here, this is going to be the vertex form that we're working with today. Shouldn't be your first experience with the vertex form, so we're going to play on that a little bit. Our goal today is using this vertex form to help us find and graph with the features that we can see in it or quickly pull out of it. So that's what we're going to try to do. We are going to employ the use of our evaluation table so that we can see the values, because relating these features between the graph, between the function rule, and an evaluation table is important, and you need to see how they look in each one, because sometimes we work between all three, sometimes we would just work with one. So we need to be fluent with all. So with that being said, let's get into some of the things that we're going to find here. First, in the hardest one to, or the easiest one to see, not the hardest one, the easiest one to see is the vertex. The vertex is visual in the vertex form, part of the awesomeness of the vertex form. H and K then are the x coordinate and y coordinate for the vertex, which again you may be familiar with. So if we pulled those two values out and put them in a point or an xy coordinate point, that would be our vertex, which also accounts for our translations. It tells us where this function is moved, up, down, left, or right, from the vertex, from the origin. So that also accounts for our translations, which we'll talk about in a little bit. With that, don't forget that that sign in there is supposed to be negative, which means that when you pull the coordinate of h out, or the x coordinate for the vertex, it will look opposite of whatever it is in the formula. So if it looks like a negative, when you pull it out, it should look like a positive. So there is no mistake with this being h negative or minus negative h, and this being a positive h. That's correct. All right, with that being said, once we find the vertex, we're going to go ahead and use that coordinate of the x, right, our x coordinate of our vertex, to identify our axis of symmetry, which is the point where the parabola is symmetric. So you just say x equals whatever that value, it means it's a vertical line, and we're going to graph that on there. That'll be the point which we fold the parabola over. We don't actually fold it, but that would be where the symmetry would take place. Okay. Next, we need to find our intercepts. So the y-intercept should be pretty easy because we're going to plug in 0 and evaluate it. You just plug in 0 where x is and find out what comes out. Whatever the value is, that's your your y-intercept. The x-intercepts here, I forgot to write in there, so we'll add it over here. The x-intercepts, we're going to solve for those. Okay. If we can't see them, we need to solve for them. And chances are you're not always going to see them. So in solving, we just left that unit, so we should be pretty good to find those, whatever method you use to solve. At that point, we should have enough to make a graph. But sometimes it's not. It just depends on the way that the points fall. We need a good set of points to make a nice parabola, usually around 5 good points, including the vertex. So if you don't have enough at that point, if you only have 3 after finding all that information, then you might need to plug in and evaluate for a different point. So plug in a different x value. And then after that, of course, we're going to go ahead and graph. All right, now that we've talked about all that, what I'd like you to do before we continue is you're going to go ahead and pause the video and you're going to evaluate. I've given you some x values. It should be pretty handy to use. You're going to evaluate the function for me and fill out this evaluation table. And then we'll go back in and see if we can pull out everything and see it in the table. All right, we'll see you in a second. Okay, so really quickly, I want to point something out. Now that you've filled in your evaluation table, we're going to cheat ahead. Usually we'd kind of go down this list here. We're going to cheat ahead a little bit and say we know what the vertex is. So the vertex, if we pull it out of here, and the reason I'm going to show you why we're going to pull this out real quick. Let me pull this out of here. Remember, this should be the opposite. So if it says positive 2, that's our x-coordinate. So we're going to write that as negative 2, and negative 3 then will be our y-coordinate, or the k. The reason I want to pull that out really quickly is if you've done your evaluation table with those values I give you, or gave you, is that you should notice right here that these two are your vertex. And how did I know that? What I'd like you to see is the symmetry of the y values as you move away from that vertex. Do you notice how it goes negative 2, 1, going to the left, or up to the y values, or I'm sorry, up the left side of the x values, right, from negative 3, negative 4, going that way, and then you see the same pattern going positive y values, so negative 3 to negative 2 to 1 there. It's a big jump, but it works. So you can see the vertex inside the table. And again, that's a very important feature to have. That's a pattern that you need to be able to recognize, because sometimes, maybe you're in standard form, you can see the vertex super handy. All right, now that we've got that down, let's go ahead and address the direction of opening. The direction of opening comes from your A value. It's either positive and it goes up, or it's a negative and it goes down. So in this case, there is no value here, so that's a positive 1 then that would be right there. So our direction of opening then is going to be upward. All right, so now that we have that down, we're going to go ahead and pull out our axis of symmetry. We've already got our vertex, so it's probably important to grab that right away. And now we're just going to write the axis of symmetry's function rule, which would be x equals -2. So we're doing pretty good. We've got some good pieces of information. Next, we're going to go to the fact that we need to find the zeros. Now, I'm going to go to the table because we do have one, and I'm going to notice that I don't have any zeros for any y value, which means that we didn't happen to come up with them. So that means that we're going to solve for them. Okay, so we're going to solve for our x-intercepts. To do that, then, I'm going to set my function equal to 0. So 0 equals x plus 2 squared minus 3. And then, if just leaving the solving unit, you say, hey, look, this would be one that I would solve with square roots. So I'm going to go ahead and move everything away from the value that's squared. And I'm going to get -3 equals x plus 2 quantity squared. And now I'm going to square root that. That should probably be a positive there. I do apologize. I'm going to square root both sides. And I'm going to work up here. And we're going to find out that 3, the square root of 3, plus or minus, equals x plus 2. So we're almost done solving this. We're going to go ahead and subtract that 2 to the other side. I'm going to reverse x on this side just because I like it there. So I'm going to get -2 plus or minus the square root of 3. Now that's the exact answer. At this point, we're going to go ahead and change that into a rounded solution. So that we're going to graph it, because when we're graphing, we need a decimal. So that's going to make the point x equals, we're going to get the coordinate -3. I'm going to borrow this from the side over here. You can run that through your calculator. I'm cheating a little bit in that regard. So 268. So those are the two coordinates of our zeros. So I'm going to write those in as actual points over here, though. So I'm going to say it's the point -3, 0.73, and 0. I'm going to graph that. And I'm going to graph the point -0.268 and 0. All right, so we got our zeros. The last bit we need to find is the y-intercept. Now, I can cheat and I can see the y-intercept in my table, but really what we should do to find the y-intercept is go ahead and plug that in and solve for it. So I'm going to scooch this down here, and I'm going to take the function f of 0, right? I forgot what my function is. It's x plus 2 squared minus 3 equals x plus 2 squared minus 3, correct? So now I'm going to plug in 0, so f of 0 equals 0 plus 2 squared minus 3, which is just going to be 2. 2 squared is going to be 4, so I'm going to get 4 minus 3, or the point -1, or the y-coordinate of -1, which makes the point 0, -1. So let's put that here, 0, -1, and you'll notice, oh, that's not -1. Double checked. 4 minus 3 is +1. Sorry, there it is. So we got the same thing that we had in our table, which is always nice to have a little confirmation there. So now at this point, we've got enough to graph this function. So let's go ahead and do that. We know that it's going to open upward because of our a value, so we'll address that when we get there. But let's go ahead and put our vertex in first. So -2, 3, left 2, down 3. There's my vertex. I'm going to put my axis of symmetry in next. I'm going to do a dashed purple line vertically down through it. I'm going to go ahead and cross that off, and then I'm going to throw in my two x coordinates. Again, they're nice and rounded for us, but -3, so 1, 2, 3, and 7.3, so somewhere in there would be probably pretty good. And then -0.2, so it's going to be just a little bit to the left of the origin there. And my y-intercept is going to be +1, which will be there. Now, you're thinking, hey, I might need to evaluate for another point, but let's use this idea of symmetry. My y-intercept is a unique point. It's 1, 2 units away from the axis of symmetry. So that means that at that same y value, at that same y coordinate, I can go 2 units away on the other side and get another point. Luckily, because we can steal a free point from that symmetry there, we do not need to go back and evaluate for another point. We now have 5 points and we feel pretty good. Remember, when you graph this, try to round out of the vertex there. It should not be a V-shaped, and then kind of speculate through there. Don't get crazy with the curve, but there you go. There's the right side, and we'll do the left side here similarly, the best we can, to be as accurate as possible. All right. We've got our graph. So now we can identify the rest of the information that may be important to us. One, which is our increasing and decreasing interval. So increasing interval will be going up from left to right, so that would be on the right side this time. So there's our increasing interval. Let's go ahead and mark our decreasing interval, so that would be going up from left to right over here, like that. And so let's write those two intervals for us. So the increasing interval is going to be the x-coordinate of our vertex, which is going to be -2. So we'll just write that down. And we're going to say that it increases from -2, not including, because that point's the turning point, so it doesn't actually increase. And it includes all the x values from -2 all the way up to positive infinity, because that's where that goes, to positive infinity. All right, and our decreasing interval is going to be coming from -infinity on the x values, right? And it's going to go all the way down to -2. So we're going to say it decreases from -infinity, all of the x values, including up into -2, not including, sorry. Our end behavior then, end behavior should be pretty easy for us to identify. We are going up and up. It should always go the same direction for these. And we can write that as, well, let me get a little thinner pen. Not that thin. How about that then? Here we go. So as x goes to -infinity, which just means the left side, what's happening on the left, f of x, our y values, are going up to positive infinity. So that means it's going up on the left. As x goes to positive infinity, which means the right side, our y values, our x, are going also up, because it's going up on the right side as well. Our domain for this, as all of these, is going to be the set of real numbers, because it's going to -infinity and positive infinity, both left and right. Our range, however, our lowest point possible for our range, remember we're thinking y values now, the lowest point on this for our range is -2, our vertex. It's a minimum vertex. So -2 is included this time in our range, right? Because it is the lowest point and it goes up forever. Oops, no included on that, to positive infinity. All right, so now you've seen a little bit of everything that you need to be able to graph this without the table. Notice we did have the table there for support. We can see most of these values right in the table as well. So whenever you need to, result to the table. But with that being said, graphing from the vertex form isn't so bad if you can grab most of these values. All right, so we'll see you in class for a few examples.